Hey everyone, and welcome. Today, we're going to pull back the curtain on Docker, a piece of technology that is, no joke, quietly running most of the modern internet. It's an absolute game changer for anyone who writes code, and trust me, by the end of this, you're going to get why it's such a big deal.
So, to really get Docker, you first have to understand the cloud. And here's a wild fact for you. Over 90% of the public cloud runs on one operating system. Just one. And that's Linux. Yeah, from the biggest websites you use every day to the tiniest startups, Linux is the bedrock.
And this right here leads to a problem. A classic, incredibly frustrating problem that every developer has screamed about at some point. You build something amazing on your Windows or Mac machine, it works perfectly. But the second you push it to a Linux server out there in the cloud, it just breaks. This is the infamous, but it works on my machine problem. And Docker was born to finally solve it. Now, for a long time, the go-to solution for this was something called a virtual machine, or a VM for short. And the idea was, simple enough. If your code needs to run on Linux to work in the cloud, why not just run a whole simulated Linux computer right inside your own computer?
And a virtual machine is, well, it's exactly what it sounds like. It is an entire separate PC, with its own fake CPU, its own chunk of RAM, its own hard drive, all just running as an application on your laptop. It's literally a complete digital clone of a computer. Okay, so just look at this stack. It's a lot. At the very bottom, you've got your actual physical computer. Then you've got your main operating system, let's say Windows. Then you need another piece of software called a hypervisor to manage the whole thing. And then finally, on top of all of that, you have a complete, separate, full installation of another operating system like Linux. That is a lot of baggage to carry around.
And all that baggage has some pretty serious consequences. First off, VMs are huge. We're talking gigabytes of hard drive space for each one. Then they are so slow. They take minutes to boot up, just like a real computer. And on top of all that, they're resource hogs. They grab a big chunk of your computer's memory and processing power and just lock it away, even if they aren't using it. It worked, sure, but man, it was clumsy.
So clearly, this wasn't going to cut it long term. The world needed something better, something lighter, and way, way faster. And that's when the hero of our story walks in: containers. This is the technology that Docker made famous.
And right here, this is the key difference. A container is not a whole new computer. Think of it more like a neat, tidy, lightweight little box. Inside that box is your application and only the absolute bare necessities it needs to run. It's totally isolated, but it doesn't have to drag a whole operating system around with it.
Now look at this. Remember that VM slide with all those layers? Look at how much cleaner this is. You've still got your computer and your main OS, but instead of that heavy hypervisor and that entire guest OS, you've just got this one lean program, the Docker engine, and then your app. That's it. Whole layers of complexity are just gone.
And this right here is the magic trick. This is the secret sauce. Containers are so clever because they don't need their own operating system. They just borrow the core, the absolute heart of the operating system that's already running on the machine. It's called the kernel. And by sharing it, they skip the entire boot up process. That one simple idea is why they are so unbelievably fast and light.
All right, so we've seen the two ways of doing things. Let's just put them head to head. VM versus container. This is going to make everything crystal clear.
I mean, this chart just lays it all out, doesn't it? VMs pretend to be a whole new piece of hardware, so they're huge, gigabytes, and they take minutes to start. Containers, on the other hand, just put a little fence around a process, so they're tiny, megabytes, and they start in seconds. It's literally the difference between building a whole separate guest house in your backyard versus just, tidying up the spare bedroom. One is way more efficient.
All right, enough talk. Theory is great, but let's see this thing in action. I want to show you just how ridiculously easy it is to fire up your very first container. Now, seriously, this is it. Once you have Docker installed, you open your command line and type this one simple command: docker pull Ubuntu. This tells Docker to go out to this giant public library called Docker Hub and download a perfect, tiny, official template of the Ubuntu operating system.
And boom, a few moments later, you've got this thing called an image. You can just think of it as a perfect factory-sealed blueprint for a Linux system sitting right there on your machine, ready to go.
Okay, now for the really cool part. You take that blueprint, that image you just downloaded, and you tell Docker to bring it to life with this command: docker run it ubuntu. This instantly builds a brand new container from that blueprint and starts it up.
And bam, just like that, you're in.
A command prompt appears and you are inside a real, live, fully functional, and completely isolated Linux environment. That whole process, the thing that took minutes and gigs of space with a VM, you just did it in seconds with a file that's just a few megabytes. That right there is the power of Docker.
So, you see, Docker is way more than just a tool. It's a totally different way of thinking about building software. It's about freedom. It's the absolute guarantee that something that works for you will work for anyone, anywhere, every single time. And that leaves all of us with a really powerful question to think about. With that kind of speed and consistency at your fingertips, what amazing things are you going to build?